This is the BrainChip Podcast. Hear from our thought leaders about neuromorphic computing, beneficial AI, and how BrainChip's Akita is pushing AI to the edge. This podcast is a place for investors, practitioners, and anyone interested in the future of AI.
Hello, and welcome to BrainChip's This Is Our Mission podcast. This is episode 29, and I'm Nandan Nayampally, Chief Marketing Officer at BrainChip. Our guest today is Zach Shelby, who should be pretty familiar to a lot of the BrainChip community. Zach Shelby is the CEO of Edge Impulse, a company he founded in 2019, recognizing the early need for simplified development platforms for AI at the edge. Zach himself is a serial entrepreneur, an angel investor with a passion for machine learning, embedded solutions, and IoT, with many successes to his name. Zach founded Sensinode, an enterprise wireless network provider in the early days of IoT, which was acquired by Arm, enabling him to develop Arm's IoT business first as Director of Technology and later as VP of Developers. At Arm, he also helped create the BBC Microbit nonprofit foundation and launch it as a CEO to accelerate and democratize technology education for children across the world and spur creative innovation at an early age. He's an angel investor in numerous initiatives such as Amini, which envisions improving data-driven, AI-based solutions to improve economic conditions in Africa and beyond, Augmenta, which is an AR-based company, Operant, which is a Kubernetes company for security, Petasense for industrial IoT, and many more. Zach sits on the board of the TinyML Foundation and was awarded the Nokia Foundation Award in 2014 for his work on the Internet of Things. Welcome to the show, Zach.
Thank you, Nandan. Great to be here.
So I think this is great. We had a session earlier in the year where you talked to Sean, our CEO. That was a great session. I wanted to see, it's been a few months since then. How do you think the industry is trending, especially in edge AI?
Well, it's an interesting time, right? We've gone through many years of hype when it comes to not only AI, but in particular AI and edge compute, right? Both of these things have been going through a hype cycle. And I think that's caused a lot of interest, but also a lot of kicking tires, right? So we've had a lot of companies playing with the technology, learning what it's about. We've had a lot of startups jumping on to the trends, right? And trying to build things, right? To take advantage of all the interest. But interestingly, right, that's calming down. So, and I'd imagine one of my big messages this year was that finally edge AI is getting boring, right? We're falling off the hype curve towards the trough of disillusionment, which means that's where real business starts. So the biggest thing I'm seeing is that despite the economy being challenging in the tech industry, it is slower and more difficult to get budget. Interest rates are affecting investment cycles in a big way. VCs have slowed down investments into especially later stage companies. Despite all that, we're seeing a lot of growth in serious enterprise customers starting to apply AI to real applications and deploy them in large volumes. That's starting to happen finally. And I think it is related to this, edge AI is finally getting boring and real for industry, right? It's not just a hyped up thing. This is a real engineering tool to solve important problems. And so finally, boring is good. We can focus on business, right? And growing the business from here.
Perfect. And for those that aren't familiar, Imagine is Edge Impulse's conference. It's a pretty go-to conference for anybody associated with Edge AI. And I think, Zach, you pointed out something that is very, very relevant, right? Which is there's hype cycle, and then there is actual delivery. Usually, there's
inversely proportional.
Exactly. And so it's good to see that, especially to some extent, you guys are a bellwether to some of the activity going on, real activity going on in development of edge AI applications, tuning of models, etc. Can you give us a little bit of an idea of how you've seen that trend go forward? What kind of activity are you seeing on your platforms? How are you seeing those go to production?
Yeah, so we're seeing, two ends of the activity, right? We have a very large ecosystem encompassing engineers already at the student level. So we actually have a large developer ecosystem. We start with university programs, and we're there to train engineers, right, on how to use AI technology to solve real sensor, right, audio, embedded computer vision applications with this tooling, right, and then deploy it to real hardware. We're training the whole industry on how to do this. So we need a large developer ecosystem to do that. So we've seen a rapid increase in the size of that developer ecosystem. Over the first 3 years of Edge Impulse, we grew to around 50,000 developers. And then in this year alone, we've doubled that, right? So the time it took us to get to 50,000 developers, we've now doubled that in 1 year. So in 2023, we've gone from 50,000 to 100,000 developers very rapidly. So we're seeing an increase in the size of the engineering community, right, that knows how to use this tooling. On the flip side, right, we're seeing enterprise customers who we focus on, right, providing professional tools to enterprise customers in industrial segments, in logistics, and in healthcare and medical devices, right, increasingly adopt the technology and put it to real production use. And a couple examples of that are HP Polycom with wearable headsets for professional use. We've had a couple of headset models now go into mass production. We have several health and medical device companies going into very interesting production and things like glucose monitoring, medical cough detection, Aura, who we worked with for a long time in wearable sleep, and now even stress detection has been in production for many years. And on the industrial side, we have an amazing breadth of customers from manufacturers, for example, in the beverage industry, to logistics companies looking at pallets, all the way through to elevators, right? And how do we improve elevator maintenance?
That's pretty cool. Hey, Marvin from Hitchhiker's Guide comes to mind. But jokes apart, I think 2023 is not yet done, and you're already doubled in size. So there's still kind of runway to grow that a lot further. In terms of the actual number of projects, last I heard, you were in close to 100,000, and that was early in the year. Has that also been burgeoning?
Yeah, so we have a couple of different indicators of like the level of activity in our community. Yes, one of those is how many machine learning projects are people working on? And for us, machine learning projects these aren't like, oh, I took a YOLO model, right, that somebody else trained, and now I'm just going to use it. It's not a model zoo. These are actually custom data, custom projects that custom machine learning algorithms that people have trained. We just broke last week, 250,000 projects.
Wow.
So that's grown very quickly. 250,000 projects that have been built, all custom.
Yeah, that's also seems to have more than doubled in the last 12 months.
Yep.
That's pretty
and then
impressive.
maybe even more interesting kind of like indicator for where the industry is going is that we track compute time on our infrastructure. And so that's the time that developers spend training things. We don't track inference time in the field. That's all private, right? Our Edge Impulse, like we output the inference models, but we don't touch them, right? Our users own those, and they get deployed all over the world. And that's probably massive compute inference time by now. But just the training time on our infrastructure is approaching 1 billion seconds of compute this year. And that's growing 30% quarter on quarter. So the growth in compute training that people are doing, right? The time they're actually hitting buttons to go, hey, transform this data set into features and then, train this machine learning model, right, with this data set and then test it. The actual time spent doing that on compute is growing fast. So that's a good indicator that people are using this more and more.
Well, that's pretty good. Those are pretty good signs for the industry as a whole, right? And in fact, part of what we're seeing through BrainChip as well is that it's not just the fact that you're training more. I think you need to be efficient at that training. So are you seeing your developers, users actually come up with models that are more intricate in that regard, which are easier to train or take shorter amounts of time relatively to train, because that's actually a big cost as well?
It is. And I think the whole point of the type of machine learning engineering automation that we provide, right, with these types of tools, it's not that different than, Nandan, you're familiar with silicon EDA tooling, right? Design automation and silicon design's been in use for a long time. And part of that, the purpose of that is to accelerate, right, and simplify the design cycles. We're doing similar things with this machine learning engineering tooling that we provide, in that we're doing things like a lot of heavy transfer learning in models and bringing out more foundational models that you can transfer learn with your own data sets without having to have, 500,000 images in your data set, right, to achieve the type of accuracy you're looking for. You can build on that work that's already done by us and transfer learn it with 1,000 images or even 100 images, very specific to your application. And the training time is, order of magnitude or two faster. So we do a lot of this kind of like optimization of training time as well, because that is wasted engineering time, right? And that it makes it hard to get to market. But even more so, right, you don't have, if you need to do a large model, complex model from scratch, most companies and most engineers will not have the data necessary, because it is all about data. And so it really comes down to how can we reduce the amount of data that you need to build a model.
I mean, well said, right? I think we're very much in line with our thinking here, especially the economics of edge AI and the types of models, especially if it needs to proliferate, the types of use cases that they need to proliferate are not necessarily exhaustive, very, very large data set model, right? And so the mindset on how you actually develop for the edge needs to incorporate how do you build out models that can train for the types of use cases with a lot less data. So I think what you're talking about is very much resonant with our understanding of the market and what we've seen from our customers.
Yep, we hear this day in and day out from customers. Like, I want to work on this application. I don't have much data or any data to start with, right? How do I get the data, right? Or create it, and what's enough? And so we're all the time providing new tools and better understanding of like, what data do you need? What more data do you need? How much data do you need? And how can you apply better techniques to get away with less data? Those are all very high value things for developers that are working on these problems, and for the companies, right, that are trying to understand where should they be applying AI, right, and what's the best practices for data.
Exactly, and that's actually, if it's a minor plug, right, that's how we came about the whole temporal event-based neural net capabilities that we're talking about. How do you actually make it easy to train, learn faster with less data, and actually be as accurate or as accurate as necessary, which is the other kind of vector that for production systems you need to kind of adhere to.
Yep.
So let's kind of build that out. You talked about a number of applications and use cases that you're seeing. I mean, we're also seeing a lot of interest in what I term aspirin use cases, headaches that we solve with edge AI rather than vitamins that make it better, right? That you can't do today if you had to build a device that was highly complex in compute, or try to get real-time response from the cloud. Healthcare and wearable devices that have intelligence and privacy are part of it, which you kind of mentioned. Audio devices, especially hearable, hearing aid type devices that have very small form factors, need to be more intuitive now. Could you go into a little bit more about that? And in fact, imagine you had the concept of the Omniverse. Can you bring those concepts together, please?
Yeah, so especially in industrial environments, right? So in the health and medical side, data is a lot about clinical data, right? We're in clinical laboratories with nurses and doctors collecting stacks of data sets with reference medical sensors and all this. That's an entire data process in itself that we enable. And we know how to get that data, and it's got to be medical grade data, right? And it's got to be clinical to give the quality that's necessary to build these algorithms that are wanted in the market, right? So that's what happens in the health and medical side. Now, we kind of need the equivalent of that in the industrial side. And the problem in industrial is that getting a hold of data from a manufacturing line when you're doing, for example, vision-based quality analysis can be extremely expensive or even impossible, because some manufacturing lines haven't been built yet, right? They're in design. Think about oil and gas. Some of this equipment is in extremely dangerous environments, very remote, right? It might require a plane plus a helicopter to get to, just to do some data collection, right? So now we're talking about very expensive data collection, or just maybe too dangerous to send humans into, right? To safely be able to collect data. This is a really common problem. And we're working with Nvidia on a really interesting technology called Omniverse to help solve this problem for especially the manufacturing industry. And what Omniverse does is it allows us to build a completely photorealistic digital twin of any environment. And that sounds very generic, but actually it gets very specific when you think of things like manufacturing lines. So at Imagine, we talked about a case that we've been working on for Pepsi manufacturing lines, where we're looking at how do we detect errors or different problems in bottling. So for example, in cans, are there printing errors, right? Are there denting? Are there other kind of malformations in cans, right, as they're coming off the assembly line? How do we generate the data that we need to train the models for detecting these kind of errors? Doing it in an actual assembly bottling facility could be very expensive. A lot of these are still being built in new places. So we've used Omniverse to go simulate the entire assembly line. And what we can do is with Edge Impulse, we have a replicator, what's called a replicator plugin for Omniverse that we've developed with Nvidia, that allows us to gather photorealistic camera angle data directly into Edge Impulse datasets. So we can basically put a virtual camera on that Pepsi manufacturing line, use it to take snapshots of lots and lots and lots of cans coming down the assembly line, all kinds of angles, every kind of lighting, right, that you can imagine, every kind of defect you can imagine. And we can automatically build up a data set and use our tools for auto labeling, some of which use foundational models, by the way, to speed that up. And we can build a completely virtual, or completely synthetic vision data set for manufacturing quality. So we're using Omniverse for enabling this kind of thing.
Oh, so effectively, you're simplifying your developers' challenges by helping with or simplifying data gathering, or reducing the amount of data that needs to be gathered through simulation, adding the auto labeling parts of it, and then making that effectively a less human intensive task.
Yeah,
or
and
develop.
something that we can do cost effectively. Yeah.
Yeah.
Faster. And sometimes just even to make it possible, right? And this is all coming back to the data discussion we had, right? A lot of these companies don't have the data for this, right? It doesn't exist. How can we create it? And then how can we test it? So that's the other interesting thing. With Omniverse, we're also able to deploy the Edge Impulse generated machine learning model, the vision model, to detect the defaults in the defects in these cans. We can deploy it back to the Omniverse, right? We can deploy it back to the virtual assembly line and test it. Test, how does the model do, right? What if we change things, right? What if there's a new type of can? What if the lighting changes, right? What if the angle changes? We can actually test it in that environment. Or we could deploy it to a real manufacturing line and test it in real life. So we've seen cases where we can train a model on completely synthetic visual, Omniverse generated vision data, and then deploy it to the real world. A model that's never seen any real world image data before. And that becomes very interesting.
These are kind of the building blocks effectively that start making the edge activity much easier to develop, right? So effectively, you're setting it up so that you can enable customers or partners to scale. So we've kind of, already broached the topic of Nvidia's Omniverse. You had a couple more announcements around Nvidia at Imagine. So let me start with this, right? Clearly, Nvidia is a leader in the space. They have built a phenomenal ecosystem apart from their compute capabilities and domain expertise in AI. Do you want to go into a little bit about how you kind of learned from that space and how you interact, and what are you doing today with Edge Impulse and Nvidia?
Yeah, an important thing to understand about Nvidia is that Nvidia is not a silicon company. People often misunderstand that, right? They're like, well, Nvidia is a silicon company, right? They make GPUs. Well, yes. But I think really Nvidia is more of a compute company. And within compute, right, where they're the 1,000-pound gorilla is in AI. So you can think of them as a compute and AI company. And Nvidia works on a ton of very valuable foundational AI models. They're investing billions of dollars in creating and training and bringing the state of the art into these models, and tooling, right? Tooling frameworks that are useful when you're applying these type of models. And we started working with Nvidia long ago with things like Nvidia Jetson, right? So bringing GPUs into smaller edge compute. So typically when you think about, well, how do you work with Nvidia? Well, on the edge, you enable things to be deployed to Nvidia Jetson. Great, we do that, right? We've done that for a long time. With Edge Impulse, we're taking that a huge step further, right? So we started working with Nvidia on a new set of technologies called Nvidia Tau, and a new partnership where we can now bring Nvidia foundational models. Edge Impulse is working on more appropriate versions of these foundational models, different model sizes, right? For all the other compute, right, that we need for production optimized deployments of models. So not everything can be in Nvidia Jetson that gets deployed in the field. There are industrial requirements, power requirements, size requirements, you name it, right? That requires a lot of different hardware. That is the reality of embedded hardware, right? We need a lot of heterogeneous hardware. We're now able to take NVIDIA foundational models, produce appropriate sizes of them, and within Edge Impulse, right, choose those models, apply a much smaller custom data set, right? Just the thing that you're looking to detect in an image, right, or in some audio, and train that on Edge Impulse very easily, very quickly. So reducing the training time, but taking advantage of a massive, very complex NVIDIA model, for example, the latest vision transformers. And then we can automatically deploy that model to any of the edge compute that's in the Edge Impulse ecosystem. So that means we could deploy Nvidia foundational models not only to Jetson, which is great for R&D and great for a lot of high-end deployments, but also to Qualcomm targets, TI targets, NXP, IMX 8M, as well as RT, right, MCU-based targets. Renesas, RA and RZ, right? Aleph Semiconductor, ST, Infineon, right? Even all the way down to things like Sentient. We can deploy across this whole scale of silicon vendor infrastructure on all the architectures, right? ARM architectures as well as BrainChip architectures, while doing that. And this is a big deal. This is probably one of the biggest announcements of this year. And we have developers very excited, enterprises very excited about this, our whole ecosystem excited. We're really doing a lot of work to make sure this is something everybody can make use of.
I think this is pretty seminal to the transition of kind of compute, or hybrid compute as people call it, right? And you have various terms, distributed, hybrid, whatever, having some happening on the cloud, but also more happening on edge devices, right? So you are going to have to break down compute because of just the sheer scale. The statement was, especially foundation model, Gen AI type models, search costs went up almost 10x in some of these cases, right? So you have to find better ways to be able to do that if you want to scale them at the edge. My question here is, obviously, a lot of these models are large for purposes of accuracy and just the size of the data. As you kind of go from these layered versions that go from higher end to lower end, how does accuracy scale, and does Edge Impulse help provide the scoping, right? So as you start reducing scope effectively, you can still maintain accuracy to some extent, but it doesn't have to be in all conditions at all times. Is that correct? Effectively a way to think about this?
Yeah, we have a few trade-offs, right? One of the major trade-offs is that most large foundational models try to be everything to everybody, right? When you have a large model, for example, a advanced object detection model, usually what the designers of that model are trying to do is go, oh, this model is so hard to train. Nobody in their right mind would ever try to do this and probably would fail. Thus, we're going to build in 1,000 image classes, right, to this model. YOLO comes to mind, for example.
Right.
And then what developers will do is they'll just take this model from the model zoo, they'll deploy it as is, the whole thing, and then they're going to play and fine tune with the outputs of that model to just take the classes that they're interested in, ignore everything else. But all that complexity is in that model still. So you're burning, 100x more compute than you really need to,
right,
in order to run that foundational model. What we do with Edge Impulse is that we're making trade-offs like, well, we don't need 1,000 classes of image detection in this small edge device that's looking for 3 things, right? Maybe looking for only 3 classes. And that's very typical, right? We're usually dealing with a very small number of classification goals or a regression goal, right? We're not trying to solve every problem in the world on an edge device, but very specific problems. So how can we go from 1,000 classes to 10? Use the kind of the foundational understandings that model has built in. So the model will learn things like shapes, right? Color gradients and things like this. And it will attach onto those as part of the neural network process as you go deeper into the network. We can slice that, right? We can simplify the size of the model to make it appropriate for 10 classes or 100 classes, right? And then we can transfer learn on the actual data set that's needed for those 3 or 10 or 100 classes from the actual industrial use case, but take advantage of that massive data set that was already in the foundational model and the architecture of it. And so this is a way that we can reduce the size of the model without losing accuracy for the appropriate scale of application, right? So going from 1,000 classes of images that we're looking for to 100 or 10. The other thing that we can play with is inference time, right?
Mm-hmm.
How fast does it have to be? Could it be a bit slower? Can we change the architecture slightly to make a trade-off in time? That's a big trade-off that we have. And then sometimes we can trade off a little bit of accuracy, right? We don't always have to be the threshold for accuracy doesn't always have to be as high as we think it does, because these applications have other things that we can do to improve accuracy. So for example, what's your posterior processing, right? How many images can you look at before you're sure enough, right? Are there other signals that you can look at the same time? For example, sensors, right, or audio
Mm-hmm.
in combination with computer vision to improve your accuracy. So there's other things that we can do to improve production accuracy. It doesn't all have to be in the model. And so that's a trade-off that we can make as well. So we have a lot of tools at our disposal to go from a gig-sized model, which we sometimes see, to 100 megs, and then to 10 megs, and then even down to 1 meg, as long as we scope how complex that we want the end model to be.
That is pretty cool. And in fact, we are seeing the same approach, right? The philosophy is the same, right? And in fact, the temporal event-based neural nets that we were kind of looking at, we started seeing activities around, BERT class, GPT-2 class right now that provide, better perplexity scores on Wikitext 103, right? In fact, better than GPT-2 right now, while being 2 to 3 orders of magnitude better in terms of size, which is necessary for it. And in terms of operations, it's not just size, because the level of compute you require for these is still high. And how do you maintain that accuracy while managing size of model is, I think, fundamental, right? And I think we are going to have some fun times over the next year or so as we integrate our activities with yours. For those that aren't aware, I think BrainChip was the first IP partner for Edge Impulse and has been part of the very tightly coupled partnership with Edge Impulse tooling. And we're pretty excited with where what you're doing right now is taking us, Zach. So if I may, right, you are seeing these foundational models come closer to the edge. You're enabling all of that. What do you see as the primary use cases at the edge for generative AI, for foundational models, for LLMs?
Yeah, so surprisingly, most of the best applications right now are not at the edge. So interestingly, when you start talking beyond other foundational models, right, like generic vision transformers for object detection, or Whisper for NLP, for example, or segmentation models, that's the kind of thing we do see deployed to the edge today, right, are these kind of more well understood foundational models. When you get into generative AI, the places where we're seeing this be most useful today are in automating the engineering process itself for the developer, rather than putting LLMs necessarily on the edge devices themselves. So we've been applying generative AI already to synthetic data generation. It's not ready for prime time. We don't see industrial customers, just using DALL-E to generate images to be used in a real industrial grade, image detector. It's very dangerous. Where do those images come from? Can we reproduce them? Do we understand why they look like this? It's not so easy to control, but we have done it to show, at least as a proof of concept, that you can use generative AI to generate images. Maybe more interestingly, right, those same models can be used for improving the ability to label. So we are using, for example, foundational models like Segment Anything adapted for our own applications from Meta. We host that in our own infrastructure, build a bunch of stuff around it, and kind of specialize the model to auto label, right? So we're actually using like big segmenter models to auto label imagery and find the interesting pieces of images that we want to use as labels, and then completely automate that. That is something that we're doing today. That's one of the most useful kind of foundational models we're seeing. And we can do the same thing with Whisper and NLP, right? Use very large models for natural language processing to do things like, well, we have a big keyword spotting data set that is unlabeled, right? Or maybe even generated first. We may generate a keyword set. How can we use a model like Whisper to auto label it and save a huge amount of time? This like generating data and labeling data, I think, is the biggest killer use case right now for most of these models.
And since you already mentioned Meta, we've seen a lot of activity on this, on the Qualcomm Meta side on Llama 2 and foundational models / LLMs, arguably at the edge. How does your work dovetail with it? What do you actually see happening in that space? Does that help accelerate more interesting applications?
Yeah, so I think the first area we're going to see actual edge deployment of this stuff is really more on the how do we better understand, for example, human speech, right? Before we get into understanding what people mean, right, and want, and how do we answer them, how do we understand what they're saying, right? On most edge compute, like speech interpretation has been pretty simple, right? Keyword spotting, very simple commands, right? With a very narrow language and dialect. How do we really understand what people are saying, right? With privacy, right on the edge, no internet connectivity, no Alexa sending your samples to the cloud, right? That's what happens today. How do you really do that? And so that's where models like Whisper, right? And how do we optimize Whisper down for the types of compute we do have available, right on the edge? That's a really interesting space. So one thing I talked about in Imagine is some work that Useful Sensors is doing, led by Pete Warden.
Yeah.
And they've been starting to work with things like, how do you put an entire kind of transcription plus understanding set of models in a box? And they call it, LLM in a box. But the most interesting commercial application of right now of that is things like medical transcription, right?
Exactly.
You have a radiologist working through a big stack of their work. It's a very slow process for them to write or just audio record and then later have a secretary come and turn that into words. That can't be internet connected. Oftentimes that doesn't work. It's not reliable. It's not private, right? It's very sensitive when you're working with clinical data. How could you do that right on the edge? That's an interesting application that we've talked about. LLMs more broadly, right? As in trying to naturally understand what someone's asking and give an answer based on a large amount of text. I think the bigger problem there is that for most industrial or medical applications, right, where we see the real business, what is an LLM going to do that is reliable for the business, right? And I think that's the biggest problem right now. It's not about the size of LLMs. We have the capability to go optimize LLMs, specialize them, cut them down to make them smaller, that we're getting towards more interesting edge deployments that could be feasible from a technology perspective. But how do we deal with the reliability of LLMs, right? I'm working on a jet engine, right, as a mechanic. I need to know, is this part appropriate and certified, for example, for this engine type and for this airline? I need the correct answer, right? Every single time with a reference, right?
Yep.
Or I'm working on troubleshooting something in a manufacturing process, right? That could bring down a whole manufacturing line if it's done wrong, right? That could be millions of dollars lost per hour. I better not mess that up because an LLM gave the wrong answer, right? And because it didn't know, right? And today LLMs have a lot of problems with, if it doesn't know the answer, right, it will make one up. And that's still especially dangerous for, it's okay if you're just having fun chatting with ChatGPT.
Yeah,
In real industrial applications, or even worse, in
exactly.
medical applications, they could be disastrous. So I think there's a lot of work to be done still to harden and make LLMs absolutely reliable and predictable
Mhm.
for these types of applications. When we do manage to do that, then I do see that there's a lot of interesting things we can do to optimize the same way we've done with computer vision models, object detection models, NLP models, optimizing LLMs down to run on appropriate edge hardware.
Mhm.
This is achievable if we can scale them down, right, to the size of knowledge that's appropriate. So instead of,
Indeed.
like we talked about these foundational models for computer vision, right, instead of
Mhm.
trying to solve for 1,000 classes of any thing that a camera might see, right, which is what foundational models try to do. LLMs are kind of similar, right? Instead of trying to boil the ocean of all text on the internet, could we train an LLM off of a foundational LLM model, but only on the maintenance manuals for a particular machine, for example, very, very specific, and make it completely reliable within that scale of knowledge? That would allow us to go a lot smaller, something that could run on an Nvidia Jetson target.
Indeed. In fact, we're actually seeing interest similarly on transcription in terms of um, actual small phraseology, right? As opposed to, I mean,
Yep.
we're so far away from keyword spotting now. But also, as we think about augmented reality type applications, or even industrial versions of it, kind of scene creation, or as you say, synthetic um, inputs, shall we say, into the solutions and to the scenarios, right? So this sounds like a pretty good point to probably table our discussion for session 2, which I'm sure we'll have over the next few months. Having way too much fun. It's already like well past our time, but it has been a very, very fun conversation, Zach. And before I thank you and sign off, are there any interesting things that you'd like to see in the next 6 to 12 months from the industry, or expect the industry to see from you?
Yeah, I think that the next frontier for me in the industry is, how do we make sure that we're educating customers on best practices, right? How do they succeed with the right hardware that's stable, highly available, right? Well understood. I think we need to give these industries, right, very clear access to the technology and understanding of what it can do for them.
Mhm.
That's I think the big thing right now. As it gets boring, right,
Yep.
the tools have to get very clear for industry, and that will accelerate adoption, help people understand what they can do. So let's not make up more exotic gadgets and even more exotic research, right? A lot of industries don't need that, right? We have enough models, enough architectures, enough techniques to do these things. What they need is stability and guidelines. So I want to see a lot more of that this year. And that's something all of us in the industry can do, right, to make their job easier. Because they're not looking for more exotic innovations, right? For example, most customers don't need to do anything with LLMs or NLP or anything like that, right? They just need to
Yep.
solve a computer vision problem on a manufacturing line that's very, very specific.
Mhm.
And then they need to be able to produce it, right, efficiently, maybe even run it on battery power for
Mhm.
years at a time. That kind of thing, right, is what they need to be able to solve
Exactly.
today, and they're willing to pay for, right? They're very high value problems.
Indeed. Well said. And again, thank you so much, Zach, for coming on board. This has been a really um, exciting and enlightening conversation. I'm sure we'll have more to discuss in the not too distant future. So, congratulations to Edge and Bolt for a lot of what you've achieved over the last, especially the last year, seems to be ramping up, and all the best going forward.
Thank you, Dan. Thanks for having me.
Thanks for listening to the BrainChip podcast. Please remember to rate and review on your favorite podcast platform.